Okay, so what we don't want to do is we do not want to square root negatives. We want to avoid it if possible. So what I would do here is I would probably look at the inside and let's remove a negative like this. So let's take out a negative from this, this, and this. That'll give us x squared plus 2x minus 15, okay? And this is the same as negative. This here has the factorization x plus 5, x minus 3, because 5 times x would be 5x. This is negative 3x. That gives you 2 because 5 minus 3 is 2. 5 times negative 3 is negative 15. So I trust that we remember how to factorize something like this into these pieces. Now here's what I want you to do. I want you to take this piece and this piece, and I want you to set them both equal to 0 and solve. So we get negative 5 and 3. Now what I want us to do is to go to a number line and to make some cuts at negative 5 and positive 3. Ignore that negative for now. That really doesn't matter right now. So what I always want to do is I want to set the inside of the square root, basically set the parts equal to 0, so I know where to make my cuts. A cut here, a cut there. Now these green numbers are going to be test values. So you see negative 6 lives here. 0 is a number between negative 5 and 3, and 4 is a number bigger than 3. Now what I want you to do is to take negative 6 and test it. Does it work? Yes or no? Could I safely take the number negative 6 and plug it in there and there? Let's see what happens. Let's test negative 6. Plug it in there and there. So this would be like the square root of negative 6 plus 5, negative 6 minus 3. Well, let's see. This would be negative. That's negative 1, and that's negative 9. Negative times negative times negative is negative. So you would square root negative 9, and bro, that's bad because we're square rooting negatives. So does negative 6 work? Nope, it does not work, nor does anything that lives in this location. What about the number 0? Test 0 by plugging it there and there. Does it work? It's a yes or no situation. Let's try it out. Plug in a 0 there and there, and you'll get back, if you plug in 0, I believe that you get back the square root of positive 15, and I can square root 15 because it's positive, so this is okay. That's all good. What about the number 4? Take 4 and plug it in there, and let's see if it works. If you plug in 4 there, 4 plus 5 is 9, and then 4 minus 3 is 1. That's going to give you a negative 9. So again, we're square rooting a negative, which is bad. So no, 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 no. So everything before negative 5 is trash. Everything after 3 is trash. But what about negative 5 and 3 themselves? Could x be? Could I plug in negative 5 in there safely? Let's see. Plug in a negative 5 there. Negative 5 plus 5 is 0. Negative 5 minus 3 is negative 8. All of this is just 0. Can I square root 0? Yes. So yes, I can use negative 5, and you can show that you can also use 3. So darn it, what's the answer? The answer is that you and I have permission to use values of x that are bigger than negative 5, but negative 5 included, all the way up to 3 included. So my answer would look like this. What this means is I can go from negative 5 all the way to 3. Now, a bracket means that you can actually use that number itself. I can use 3 because there is a bracket. So a bracket means you include that number. A parenthesis would have meant that you cannot use that number. This means that numbers that are bigger than negative 5. So we'll come across this situation soon. For now, this is the answer for my domain for this function. So domain is a collection of numbers that we can safely use. For this problem, the numbers that we can safely use are from -5 to 3, where both -5 and 3 are included. Okay, for this problem here, you have to remember that when you go natural log of some quantity A, you have to make sure that that number A is bigger than 0. Whatever A is, it has to be a number that is bigger than 0. It cannot be 0, and this number cannot be negative. It has to be anything bigger than 0. So for that reason, if you want this function to work properly, you have to make sure that the stuff in the parentheses, 4t minus 7, you have to make sure that it's bigger than 0. And that's why I jotted this down. I said, hey, 4t minus 7, whatever you are, you got to be something that's greater than 0. Now let's solve for t. So let me add the 7 to the other side, and then let me divide by 4. And this tells me that the numbers t that I use, then whatever I plug in for t, it can be anything in the whole wide world that is bigger than 7/4. So what would my answer look like? It would look like this. It would look like 7/4 all the way up to infinity. But because I cannot use 7/4 itself, instead of a bracket, no, it would be a parenthesis. Now, the infinities pretty much always have parentheses. Later on in like really fancy math classes, the infinities might have a bracket. But for now, your infinities, whether it's positive or negative, they'll always have a parenthesis. So this would be my domain for this function. From 7/4 up to infinity, this is excluded. Okay, so for a problem like this, what I would try to do is I would try to factorize things if possible. For instance, in the top, inside the square root, you have this factorization. And in the bottom, you can actually take out a 7, and you'd be left with this here. But you know what? That denominator, you can break it up even more and more and more. You see, in the bottom, you have a difference of squares, as they call it. Right? First, I took out a 7, but then I said, hey, the inside, that's x plus 3x minus 3. Now, what I want you to do is mentally set this equal to 0 and solve. Set this equal to 0 and solve. Set this and this. Anything with an x, set it equal to 0 and solve. Because that's going to tell you where to go on the number line and where to make your cuts. So what I'm going to do here on my number line, let's draw a number line. I'm going to make a cut at -3. I'm going to make a cut at -1. I'm going to make a cut at +3 and then at +8. And then what I'm going to do here in blue is I'm going to select some test values like we did before. So a test value, for instance, that lives here would be like -4. A test value here would be like -2, 0, 4, and then like 9. So let's take these blue test values and let's test them right here to see if this works, yes or no. Now, before we do that, I want to remind you of two things. Number one, you do not want to divide by 0. We don't want to divide by 0. Also, we don't want to square root negatives. So let's see. Why don't we test the number 0? Is 0 okay, yes or no? If I plug in a 0 here and there, this would be -8 times 1, which is -8. So I would be square rooting -8 if I plugged it in there and there. And that alone is bad. You see, I don't care if 0 works in the bottom because 0 fails in the top. And it fails in the top because if you plug it there and there, you're going to end up square rooting a negative, which is bad. So for that reason, 0, nope, bad, 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 bad. What about, let's say, -4? Can I safely use -4 here, 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 and here? Try it. Plug in -4 there. That'll be -12 times -3. Negative times negative is positive. So you're going to square root a positive, and that's okay. If you plug -4 into the bottom, you're going to get some number that's not 0, and that is also okay. What you don't want is for the bottom to become 0 or the top to be a negative square rooted. So I'm going to say yes to -4. What about -2? Is -2 okay in the bottom? Sure, because it doesn't create a 0. But is -2 okay here and here? A -2 there would be like a -10. And then a negative there would be like a -1. And if I multiply these, that would be +10. And I'd be square rooting a positive. So that to me looks okay. So I'm going to say yes to these numbers there. What about +4? Can I plug in 4, 4, 4, 4 there and there? Let's see. If I plug in +4 there, that's 5. Here would be 4 minus 8, which is negative. I would be square rooting a negative, which is terrible. So this would be no, 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 no. What about +9? If I plug in 9 there, 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 I think that would be okay to do. So I'm going to say yes. The only thing left to do to get an answer is decide if these numbers themselves are okay, yes or no. Well, I'll tell you what. I can tell you right away that the 3 and the -3 are not welcome, because if I plug in a 3 there, it would be 0 times this, which is still 0, and I'd be dividing by 0, which is bad. -3 is bad because if you plug it in there, you get a similar situation when you're dividing by 0. What about 1? What about 8? If I plug in either -1 or 8 into the top, I would be square rooting 0, but that's okay. You can square root 0 because the square root of 0 is just 0. So I would say that yes to these guys, no to these guys, and yes to these ones, and yes. So what the heck does this answer look like? Let's write our final answer. And let me just put it like up here. So let's move from left to right. So all the way left is over here. This is -infinity. We're coming this ways. We're going from -infinity, and this is a yes, but this number -3 is a no. And let me get rid of the blues, because the test numbers no longer really matter. All that matters are these guys along with the yeses and nos. So my answer goes from -infinity. Now I know it says yes, yes, but the -3 was a no. So I have to exclude -3 like this. And I'm going to put a union, and I'm going to jump over -3, but I'm going to include all of this because this was a yes. And this is a no, so I have to cut it off there. So I'm going to go from -3 to -1. However, the -1 was a yes, so that would be a bracket. And then this is no, and this is a yes, and that continued from 8, which was included, and it goes from 8 to forever and ever and ever. And these are the union symbols. This is called a union symbol, and you use a union symbol to combine intervals together. This is called an interval. This is called an interval. So this here, this really technical problem, which it was, that'd be the domain for this function. Right? It goes from here all the way to there with excluded, excluded, included, included. Let me just make a quick example. Let's say I had like x to the power of 5 plus x to the power of 13. How would I factorize something like this? I would actually be able to take out x to the power of 5, and I would be left with 1 plus x to the power of 8. You see, the idea is if you have an object repeating, and if you have some powers, what you can do is you can take out, at most, the smaller of the two powers. So between 5 and 13, I could take out x to the 5th. I was left with a 1 because in my head, if I distribute, 1 times x to the 5th is x to the 5th. And then x to the 8 times x to the 5th is x to the 13th, because 5 plus 8 gives you back 13. So that's the idea that I want to apply to this guy. So in this main problem here, notice that there are two main clusters. There is a cluster here, and there is a cluster here. Now, what do these clusters have in common? Well, for sure, they have this repeating set of parentheses. I have this power 8. I have this power 7. So what can I take from these guys? What's the most that I could take away? Well, this is 8 and this is 7. So I can take away this to the power of 7. So check this out. I have 4x squared plus 1 to the power of 7. Let me open up some brackets. So if I take this away from the first piece, what would I be left with? I'd be left with 3x cubed, and I'd be left with that extra additional copy of this guy because this one could afford 8 and it lost 7, but there's one extra. Now, what if you take this away from that? I would be left with 64 x to the power of 5, right? Because I took all of these, all 7 were deducted from this guy, so all that would be left here is the 64x5. But look, take a step back, and I want you to see that we're not finished yet, because there's something else we can take away. What does this have that this also has? X's, some extra x's. This has 3 extra x's, and this has 5. So I can actually take out x cubed to the front out here. So let me take out an x cubed to the front, along with the baggage that was already out there, and let's see what would be left inside. So if I take away x cubed from 3x cubed, I'd be left just with a 3, and then the stuff that was already there. Plus. Now if I take away x cubed from this, I'd be left with a 64, x to the power of 2. Because there were 5 copies, we took away 3 of them, so we're left with an extra 2. And this one, you don't really have to write it. So this would be the final answer if the goal was to factorize this.